Milankovitch Cycles in Earth's Ice Age Future, the 2025 Scientific Update. Long before humans built cities, long before written history, the planet itself was moving to a rhythm written in the stars. Ice came and went. Oceans rose and fell. Civilizations unknowingly lived through a cosmic dance that shaped their fate. But what if I told you that this dance is not random? That the story of our past, present, and future climate is carved into the very fabric of Earth's movement? And what if I told you we may have been getting it all wrong? For nearly a century, scientists believed they had the answer: Milankovitch cycles, a set of slow, predictable changes in Earth's orbit, tilt, and wobble that drive ice ages and interglacial periods. But new discoveries in 2025 are rewriting what we thought we knew. Supercomputer simulations have revealed patterns we never saw before. Deep-sea sediment cores are exposing an ancient climate secret. And the latest research suggests that humanity's influence may be stronger than anyone expected. So the big question is, are we heading for another ice age? Or have we permanently rewritten Earth's natural cycles? Today, we're diving into the most mind-blowing scientific discoveries of the year: the cutting-edge research on Milankovitch cycles, climate change, and Earth's future. To understand the future, we need to unravel the mechanics of Earth's past. For over a century, scientists have known that Earth's movement through space isn't fixed. It shifts and wobbles in complex ways over thousands of years. These gradual changes in Earth's orbit, tilt, and axial wobble alter the way our planet receives sunlight. This is the foundation of Milankovitch cycles, first proposed by Serbian scientist Milutin Milankovitch in the early 20th century. He mathematically predicted that these slow, celestial rhythms controlled Earth's glacial and interglacial periods. And for decades, the evidence seemed solid. Ice core records, deep-sea sediments, and fossilized pollen all showed an undeniable pattern. Every 100,000 years, a massive ice age would grip the planet, followed by a brief period of warmth, like the one we're in now. But modern science is proving it's not that simple. New research in 2025 is uncovering hidden forces, unexpected accelerations, and even potential disruptions to these ancient cycles. Let's break it down: the three major Milankovitch cycles and what new discoveries are telling us. Orbital eccentricity, the shape of Earth's path around the Sun, 100,000-year cycle. It stretches and contracts over a 100,000-year cycle, shifting between a more circular and a more elliptical shape. This changes how much solar energy the planet receives over long timescales. During more elliptical orbits, Earth spends part of the year farther from the Sun, leading to long, deep winters that build up ice sheets. New discovery, 2025. Recent NASA satellite data suggests that Jupiter and Saturn's gravitational influences may cause more chaotic eccentricity shifts than previously thought. This means ice ages may not be as predictable as Milankovitch initially believed. A study published this year in Nature Geoscience found that eccentricity alone may not be the dominant driver of ice ages. Instead, it acts as an amplifier, working in combination with other forces. So what are these forces? Axial tilt, obliquity, the angle of Earth's lean, 41,000-year cycle. Right now, our planet leans at 23.4 degrees, but over 41,000 years, it shifts between 22.1 degree and 24.5 degrees. Why does this matter? A greater tilt means stronger seasons, hotter summers and colder winters. A smaller tilt makes seasons milder, keeping polar ice more stable and potentially triggering glaciation. New discovery, 2025. A recent analysis of fossilized coral reefs suggests that past warm periods, like the one we're in now, may last much longer than expected when combined with high greenhouse gas levels. Another breakthrough from 2025 suggests that obliquity might be more powerful than previously thought. Computer models show that when obliquity is at its highest, even small changes in CO2 levels can completely stop an ice age from forming, something never included in past models. The big takeaway? We may have already delayed the next ice age or stopped it entirely just by altering CO2 levels. But there's one more major cycle that plays a critical role. Imagine a spinning top. Over time, it starts to wobble. Earth does the same thing over a 21,000-year cycle. This wobble, called precession, shifts the timing of the seasons relative to Earth's orbit. Why does this matter? Sometimes the northern hemisphere tilts toward the sun at its closest approach, making summers hotter. Other times it tilts away at its closest approach, keeping summers cool and allowing ice sheets to grow. New discovery, 2025. A groundbreaking study using supercomputer climate simulations found that precession interacts with solar activity in ways we didn't expect. During periods of high solar output, precession amplifies warming effects. During weak solar cycles, it intensifies cooling. This means that Earth's future climate is even more sensitive to solar activity than we thought. And here's where things get alarming. For millions of years, Milankovitch cycles controlled Earth's climate like clockwork. The rise and fall of ice ages, the shifts in seasons, the delicate balance between warmth and cold. It all followed an astronomical rhythm dictated by Earth's slow dance through space. But today, we're witnessing something unprecedented. For the first time in Earth's history, one species has gained the power to override these natural cycles. That species is us. Climate scientists now believe that human activity is disrupting the very cycles that have governed Earth's climate for millennia.
How?
New discovery, 2025. A groundbreaking study in Nature climate change suggests that we may have already delayed the next ice age by up to 50,000 years, simply by burning fossil fuels and increasing atmospheric CO2. The logic is simple. Ice ages begin when summers stop getting warm enough to melt the previous year's snow. Over thousands of years, this buildup of ice expands glaciers, reflecting more sunlight and cooling the planet. But carbon dioxide levels are now at 420 parts per million, the highest in at least 4 million years. Compare that to past glaciations. During the last ice age, CO2 was just 180 ppm, less than half of what it is today. Even in the warmest interglacial periods, CO2 never exceeded 300 ppm. What does this mean? It means that even when Milankovitch cycles tell Earth to cool down, the planet can't. We've trapped so much heat that ice sheets can't expand. Ice sheets are supposed to grow when axial tilt, obliquity, is low. But instead of growing, they're collapsing. Recent satellite data shows that Greenland is losing ice faster than any time in recorded history. Scientists once believed it would take thousands of years for it to melt. Now, some predict just a few centuries. If Greenland melts, it will raise sea levels by 7 meters, 23 feet. Entire cities, Miami, New York, Tokyo, London, will be underwater. For the past 2.5 million years, Earth has cycled between ice ages and warm interglacial periods about every 100,000 years. But in 2025, new research suggests this cycle has been fundamentally altered. Before humans, the only major source of CO2 changes came from volcanoes and ocean chemistry. Today, we release 40 billion tons of CO2 per year, 100 times faster than natural processes can remove it. In the past, Milankovitch cycles helped trigger cooling trends. But modern climate simulations suggest that even when orbital changes would naturally cool the planet, excess CO2 could prevent it from happening. Translation? The next ice age could be postponed indefinitely, or even canceled. Instead of a slow natural cycle, we may have locked Earth into a one-way path of rapid, unnatural warming. But if Milankovitch cycles no longer control the planet's climate, what does? The answer is terrifying. For the first time in 4.5 billion years, Earth's fate isn't determined by the sun, moon, or gravity. It's being determined by us. For the past 2.5 million years, Earth has followed a predictable cycle, cooling into ice ages, warming into interglacial periods, and repeating like clockwork. But now that clock is broken. And the future of Earth's climate is being rewritten in real time. Instead of gradual transitions between warm and cold periods, Earth's climate may now swing violently between extreme heat and extreme cold. Supercomputer simulations show that as ice sheets melt and freshwater floods the oceans, ocean currents could collapse, triggering sudden freezes in some regions while others keep warming. This could lead to a world of unstable, chaotic climate patterns instead of the predictable ice age cycles of the past. The Atlantic Meridional Overturning Circulation, AMOC, is a giant system of ocean currents that moves warm water from the tropics to the poles. This current regulates global temperatures, keeping Europe warm, the Amazon wet, and the Indian monsoon stable. New research shows AMOC is weakening faster than ever, possibly within decades of total collapse. As Europe could enter a mini ice age, while the U.S. East Coast faces catastrophic flooding. The Amazon rainforest could dry out, triggering mass extinctions. Africa and India could face permanent drought, putting billions of lives at risk. I've been 3 years ahead of previous predictions. The Arctic acts as Earth's air conditioner, reflecting sunlight back into space. Without ice, Earth absorbs more heat, accelerating warming even further. For most of Earth's history, CO2 levels have determined whether the planet was frozen or tropical. New research shows that if CO2 levels pass 600 ppm, Earth could permanently transition into a hothouse Earth state, with no ice anywhere. The Amazon rainforest turns into a desert. The Midwest and California become too hot for farming. Global food supplies collapse. Superstorm stronger than anything we've ever recorded. Mega fires that burn entire forests in hours. Heat waves so intense they cook human flesh within minutes. Permafrost thawing is releasing methane, an ultra-powerful greenhouse gas. Rainforests are becoming carbon sources instead of carbon sinks. Ice sheets are collapsing faster than predicted. Scientists once thought we had decades to act. Now some warn we may only have years. But if Milankovitch cycles no longer control the climate, can we? The terrifying truth is we are now the dominant force shaping Earth's climate. The question is, will we destroy it? Or can we still change course? A look at solutions and the future. For the first time in Earth's history, a single species, us, holds the power to control the climate. The question is, will we act in time? New breakthroughs in climate science, 2025. Can we reverse global warming? Scientists are no longer just studying climate change. They are engineering ways to stop it. Some of the most radical solutions include solar geoengineering, spraying aerosols into the atmosphere to reflect sunlight. Carbon capture and storage, pulling CO2 directly out of the air and storing it underground. Artificial ice sheets, building structures to refreeze the Arctic. But these ideas are controversial and risky. Are we playing God with Earth's climate? Yes. But only if we act now. In 2025, renewable energy is growing faster than ever. Wind and solar are now cheaper than coal and gas in most countries. Nuclear fusion, once science fiction, is now in early testing stages, promising infinite clean energy. AI-powered energy grids are reducing waste and optimizing power usage. But here's the problem. Fossil fuel companies are still expanding. Governments are not cutting emissions fast enough. We're running out of time. Scientists warn that we must cut emissions by at least 50% by 2030 to avoid the worst impacts. But at current rates, we're far behind. What if we fail? If global temperatures rise above 2 degrees, we enter a world of permanent food shortages as crops fail in extreme heat. Climate refugees in the hundreds of millions, entire regions becoming uninhabitable. Economic collapse as disasters drain global resources. At 1.5 degrees C, we avoid runaway feedback loops. At 2 degrees C and beyond, we risk triggering unstoppable climate shifts. The Action Plan, 2025-2035. The good news, a tipping point for solutions? Clean energy is booming faster than predicted. The world's biggest polluters, China, the US, and the EU, are finally moving towards serious action. Younger generations are demanding change like never before. The next 10 years will decide everything. Will we choose to stop the collapse? Will we innovate our way out of this? Or will we watch history repeat itself, this time with us as the cause? The last time Earth's climate changed this fast, dinosaurs went extinct. This time we have a choice. What happens next is up to us. The time to act is now. If you found this video insightful, there's one simple way you can help spread awareness. Hit that like button. It tells the algorithm that this video matters. Drop a comment below. What do you think is the most urgent climate solution? Let's start the conversation. Subscribe and turn on notifications. If you want more deep dives into Earth's past, present, and future, you won't want to miss what's coming next. Together, we have the power to change the course of history. Let's make it count.